Hello, YouTube. This is UMOS03. In this lesson, I wanted to talk about math. In a previous lesson, we discovered that Java can provide arithmetic expressions, right? It can evaluate things like adding, subtracting, multiplying, and dividing two numbers together. It turns out that there's a little bit more to mathematics than just adding, subtracting, multiplying, and dividing. And we've already learned that Java provides some functionality that can be helpful to us in our programs. We've seen two examples of that. The first is in the string class, where we went to the Java API for string. And so I had you guys pull up the search engine in lessons 5 and 6 and go to string Java API. And we can look at some helpful methods that are available to us when we're dealing with string objects. In the previous video, we also looked at the scanner class, and we said that the scanner can be used, and it has methods in it for basically saving user input into variables that we can then use in the execution of our code. Now what we can do is look at another API, and we're going to actually look at literally a class in Java called Math. So what you should do is go to your search engine and type Math Java API, and it should be the first link that you see here. And we're going to look at some of the documentation that Java provides for doing mathematical operations. And you can see that this API is very descriptive. There's lots of paragraphs here, but you don't have to worry about all this, right? It's basically just saying we have methods for performing basic numeric operations, more so than just the plus, minus, times, divided, right? So just a little step up here. So now we can do logarithm, square root, absolute value, things like that. So there are so many mathematical operations that the Java programming language can perform for us. In the interest of making this a 15 or 20-minute video rather than 2 or 3 or 4 hour one, I wanted to show you the 10 or 12 or 14 most important methods from the math class that I think that you should be familiar with for future work in software engineering. So I'm just going to outline some of the methods of this list for you, and then we're going to go into our class and we're going to try out some of them. So it's going to be pretty straightforward, and we're going to be doing math the whole time. I'm going to try to go mostly alphabetically. So let's start at the top of our list. We're going to be looking at these absolute value functions. So we know that the absolute value of a number is equal to the number if the number is bigger than or equal to 0. And it would be the reverse of the number if the number is negative. So we're basically looking for the positive version of a number. So what if we say something like int a equals 2 and int b equals Math.abs of a? And then we say system.out.println of a equals b. So this is an example of a Boolean expression because we're trying to see if 2 is equal to the absolute value of 2. For a positive number, we should expect a true result here, right? Because the absolute value of 2 is 2. But then if we go ahead and change a to be negative 2, we would not expect negative 2 to be equal to the absolute value of negative 2. We would expect the absolute value of negative 2 to be positive 2. So that's the absolute value. You can do this, same thing can happen with floats. You can do the same thing with floating point numbers. So what if you said system.out.println of Math.abs of 5 minus 8.2? So you'd be talking about a negative 3.2, but that's going to become a positive 3.2 when you call Math.abs. And like I think we've seen once before, there might be sometimes a rounding error. So here we get 3.199999999. But I think you can conclude that for all intents and purposes, that would round to 3.2. Let's look at some of the other methods in the math class. So I just want to show you some of the functionality that we have available here. So let's look at another one. We're going to do the addExact method. So the addExact method literally just adds two numbers together. And they have to basically, so what we're going to do here is you could say something like int q equals 2. Q equals 6. Okay, so this is just a reassignment of Q. So this is basically, ends up becoming a meaningless line of code, right? If you're going to assign Q to 2, but then you just immediately assign it to something else, then what's the point? But I'm just going to write it like that just for fun. And then what I'm going to say is Q equals Q plus Math.addExact of 2 and Q minus 1 system.out.println of Q. So let's think about this code. So the Math.addExact method accepts two arguments and adds them together. So what is 2 plus Q minus 1? Well, the most recent value of Q is 6. So 2 plus 5 is 7. And so we're going to add 7 to 6 to get 13. So we should actually expect 13 from the output of this code, and indeed that's what we get. So add exact for adding two numbers together as if the plus sign were not a thing. Okay, cube root. What if you want to do the cube root of a number? So we know that if we have a number, then we can figure out another number where if we multiply that number by itself 3 times, we would get the number that we started with. So what if we say system.out.println of math.cuberoot of 64.0? So is there a number where if we multiply it by itself 3 times, we get 64.0? Yeah, think 4.0, right? So 4.0 times 4.0 times 4.0 will be 64.0. So then if we take a look at this, if we want a cube root, we should be able to get that. Same thing with 0. What if we said 64.0 minus 64? Well, this becomes 0.0. The cube root function accepts a floating point number. It accepts a double, and it returns a double. So now this is just the cube root of 0.0 is 0.0. Another one is cosine. So what if I want to know the cosine of a number? Well, before we go into more functions, what I want to do is tell you about 2 important mathematical constants that the math class keeps track of. So it turns out that Java knows the value of e, which is a very important mathematical constant, and the value of pi, which is also another very important mathematical constant. So what we could do is concatenate the value of pi with this string pi colon to tell us what pi is, right? And then we could also get a value of e. So now if we go ahead and compile this code and close it, and then go ahead and run it, it can tell us what e and pi are. The reason why we have that is because when we're dealing with cosine or sine, those typically accept some fraction of pi. Like we want, oh, sine of pi over 2, or cosine of pi over 4, or something like that. So now what we could do, now let's go ahead and save math.pi over 2 into a variable. So a equals pi over 2, basically, right? So or 180 degrees, if you will, right? So that's 180 degrees. So now what we do, we know that the cosine of pi over 2 should be 0, right? So then if we go ahead and do system.out.println of math.cosine of a, so you're realizing that every time we call a method of the math class, we need to write math dot. So math.cosine of a, we expect the cosine of pi over 2 to basically be 0. And this is another example of the way that the Java compiler works. As you can see, a extremely small number here, and it's a rounding error. So it basically says 6 times 10 to the negative 17. So it's basically like 0.00000000000000001. Okay. And so it's basically 0. And so it's good that we're able to verify that and go back and forth between writing code with what we understand from our math education. What about the exponential function? So we think about e to the x, right? So we know that e to the x is multiplying e by itself x times. And it's a quickly growing function, right? So e to the 10 is a big number, okay? So let's try figuring out some values of e to the x. Well, we know that e to the 0 is 1. Anything raised to the 0 power is 1. So let's do system.out.println of math.exp of 0. So what this does is e to the 0. So now if you go ahead and compile it and run it, we're going to run the hello world, and indeed we get 1.0, okay? What if you want the value of e? You could do e to the 1, right? Remember how we said you could do math.e to get the value of e? Well, you could also just do e to the 1. Let's figure out what e to the 1 is. So you do e to the 1, and you get the same thing. You get 2.71828, right? And so that's kind of how that works. You can also have logarithm. So in mathematics, we learned that exponential and logarithm are inverses of each other, right? So if you plug a number into an exponential and get another number as a result, then if you plug that other number into the logarithm, then you get the original number out that you started by, plugging into the exponential, right? So the input of one is the output of the other. Okay, so now if we know that e to the 1 is this e is 2.71, then we should be able to say that the logarithm of e is just 1. So now we should go in the opposite direction. What if we said system.out.println of math.log of Math.e, right? So we know that we have this constant that the math class stores. This is the value of e, and the natural logarithm of e should be 1. So this is like doing log of e, or ln of e. Okay, so now we're going to do compile, and then we can run it, and then we're going to get 1.0. So those are the inverse functions, and you should be familiar with how those work mathematically. Let's think about maximum and minimum. What if you want to find the maximum and minimum of two numbers? So what you would do is you could basically say int a equals 2, b equals 16. And then what you could do is you could say a equals Math.max of ab. So that means we are basically going to assign a to whichever of a and b was bigger. So a will carry the maximum after this step, even if it wasn't that way originally. So then what you do, if you say system.out.println of a, we should get 16, because the maximum of 2 and 16 is 16, okay? And this works for decimals as well. You could do this for floating point numbers. So then if we change this to, what if you just change this to doubles, right? Like this. And then you could change this to 16. What if you change this to a, what if you change this to a 2.5, right? So you're still going to get the same maximum here, but now we should expect 16.0. 16.0, because you're talking about the maximum method returns a double if it's fed doubles, but it returns an int if it's fed ints. So here, since we're feeding in doubles, it's going to return a double. And same thing with Math.min, right? So of course here, now we would be getting 2.5 instead. So hopefully that's pretty clear to you how that works. So that would be 2.5. Let's think about the multiply exacts. This is the same thing. So if you have system.out.println of Math.multiplyExact, let's try something a little bit more complicated here. Math.multiplyExact of -3, -1, and Math.multiplyExact of 1 and 10. So then what will be the output of this code? Well, Math.multiplyExact of -3 and -1, it just multiplies those together, so we get 3. Math.multiplyExact of 1 and 10 should be 10. So that means that Math.multiplyExact of 3 and 10 should be 30. So it's just a fancy way of multiplying two numbers together, and it looks like we have a spelling error here. So that's why it wouldn't run. So now we press compile and close, and then we're going to go ahead and run it, and we get that 30 that we were looking for. What if you want to raise one number to another number? So I'm just going to make a little comment here. What if we want a to the b? Here, use Math.pow of a and b. Okay, so Math.pow of a and b accepts two doubles, a and b, so two floating point numbers, and returns a to the b. So it's the, just the first number raised to the second. What would be the result of that? So let's take a look at this. So double x, y. Let's think about a, you could do any power that you want. We could do the third power or something. We'll do 2 to the third power. So we'll do 2 and y equals 3. Okay, and remember, these are doubles, right? So this is going to be 2.0 and 3.0. And so if you do system.out.println, let's do two of them. Math.pow of y and x minus Math.pow of x and y. Okay, so if you do 3 squared, you should get 9.0. And if you do 2 cubed, you should get 8.0. So we're expecting 1.0 here. So if we compile it, close it, and run it, indeed we get that 1.0 that we were looking for. Another method that you should be familiar with is the random method. So Math.random returns a random number between 0 and 1. So if you want, Math.random returns a random number between 0 and 1. So what if you want a random number between a and a plus 1? So if you do a plus Math.random, this would be between a and a plus 1. It's just adding 1 onto it. What if you want between a and a plus b? So you do a plus b times Math.random. So this would scale so that the random number is on the interval, it would be between a and a plus b. So hopefully you can understand, because it's basically multiplying and something between 0 and 1 by b. So therefore you get something between 0 and b, and then you're just adding on a regardless. You get something between a and b. So this is the formula. What if I want a random number between 10 and 14? I would do 10 plus 4 times Math.random. So I'm probably going to get something like 12. Okay, and it's going to be something around 12. Maybe it'll be 11 or 13 or something like that. So let's take a look at that. So what we're going to do is run this code. So we're going to press compile, and then we're going to go ahead and run it. And then you get, 10.96. So it has to be between 10 and 14. And then the last two that I want to tell you are about the sine. So you can do the sine of an angle. So for example, system.out.println of math.sine of math.pi over 4. So we know that the sine of pi over 4 is the square root of 2 over 2. It's actually something like 0.7. It's something like 0.7. So then if we compile it and run it, indeed it's about 0.707. The last one that I want to talk about with you is the square root. So you can do the square root of a double, okay? The square root of a double. Okay, so what if you do double A equals 81, system.out.println math.square root of A. What if you do square root of int of A, okay? So this 81, this would be an 81.0, but then you feed just 81 into the square root, but still the way square root is defined is it accepts a double. So the 81 is still going to become an 81.0 again. And then when we do the square root of 81.0, we should get 9.0, and that's exactly what we get here. So hopefully this video got you comfortable with the absolute value, addExact, cube root, cosine, exponent, logarithm, maximum, minimum, multiply, pow, random, sine, square root, and then the two mathematical constants, e and pi. Go ahead and try your own practice problems and look at this Java API and try some on your own. Maybe try one that we didn't talk about in this video, because we can use these mathematical functions to come up with more interesting programs beyond just adding, subtracting, multiplying, or dividing two numbers. From UMills03, thanks for watching, and please subscribe.